Section 12.6, we're going to look at spheres. So we're going to find surface area and volumes of a sphere. So what is a sphere? I know you have an idea of what it looks like, but it's really the set of all points in a 3D space that are the same distance from the center. So what happens here is you are going out from the center in all these different directions in 3 dimensions. And so what you have then is a sphere, or what most of you would look at and think of maybe as a ball of some kind. So surface area of spheres. Well, one sphere we could look at is a baseball, and it has a leather covering. And so to understand how the formula for surface area of a sphere is derived, we could think of the baseball and the covering. And there's kind of a picture of it here. And what ends up happening is you basically have like these 4 circles here, and on the baseball you have some extra, okay, that helps hold it together with your stitching. That's really what you have. Now, this down here is a link to a YouTube video that's kind of interesting because it's very visual, and basically think about a sphere like an orange. And if you take off the orange peel, you really are looking at the surface area. And it turns out that if you break the orange peel into small enough pieces and it will fit inside, if you trace the diameter of the largest circle, in other words, you trace 4 circles on a piece of paper and you peel the orange, you'll be able to fill up those 4 circles. So basically the surface area of a sphere is made up of 4 circles, and so your formula is just 4 pi r squared, where r is the radius. So this formula is really pretty simple to use. And we'll do some calculating of some surface area of spheres in just a few minutes. But let's look at volume. This is a little bit more challenging to understand. And so you can kind of read through this explanation. Or again, if you copy and paste this, it's really kind of a cool, challenging video for you to think about, as the sphere being made up of a bunch of different pyramids. And we know how to find the volume of a pyramid, but we don't really know how many there are. It's really pretty cool. It's a really cool explanation. I'd really encourage you to look at it. But basically, the volume of a sphere boils down to 4/3 pi r cubed. So that is our volume of a sphere, 4/3 pi r cubed. Where again, so really we only need the radius to calculate volumes and surface areas. So here are some radii of various different sports balls. Find the exact and approximate surface area and volume. So it really doesn't matter like what we pick. I kind of like to compare similar. So this is a baseball, and we'll compare that to the lacrosse ball. They're somewhat similar in size, you can see, and so we'll see how just a little bit bigger radius makes a difference. So for the baseball, the surface area of the baseball is 4 pi r squared. Again, 4 circles. So I take 4 times pi, and my radius is 3.56 squared. And so the exact, if you want to say, is 50.69 pi centimeters squared, which approximately is 159.26 centimeters squared. So that is your surface area of the baseball. So let's compare that to the lacrosse ball. So the lacrosse ball, again, the surface area is 4 pi r squared, or 4 times pi times 3.13 squared. So as an exact answer, that is 39.19 pi centimeters squared, and an approximate value of 123.11 centimeters squared. So look at just having like from 3.56 to 3.13, that's only a radius of 0.4 3 centimeters bigger, but our surface area is quite a bit larger. Because remember, it doesn't just get the same number of times bigger, it gets the same number of times squared bigger. Remember our work with that. So now let's work on the volumes now and just practice calculating some volumes. So the volume of the baseball is 4/3 pi r cubed. So that equals 4/3 pi times 10.54 centimeters cubed, which is approximately 60.16 pi centimeters cubed. Actually, that's the exact answer. And the approximate answer is 188.99 centimeters cubed. Let's do the volume of the lacrosse ball. 4/3 pi r cubed, which is equal to, I'm going to switch to a different color here, which is equal to 4/3 pi times 3.13 radius cubed, which is equal to 40.89 pi centimeters cubed, or approximately 128.45 centimeters cubed. So you can kind of look at some of these and you can go back to reminding yourself that if your radius is 2 times bigger, your surface area will be 2 times 2 bigger, or 4 times bigger, and your volume will be 2 times 2 times 2, or 8 times bigger. And we did some work on that earlier. So I would like you to try the volume and surface area for one of these, and let's just pick the same one. Let's pick this softball, and then you can check back to the notes to make sure you've done it correctly. So let's do a word problem here. It says a decorative ball filled with water has a surface area of 1,600 pi square units. How much water does the ball hold? So we're going to eventually find the volume. But first, we're given the surface area. So our surface area is 4 circles, 4 pi r squared. And we're given the surface area is 1,600 pi equals 4 pi r squared. So now I'm going to divide each side by 4 pi, which gives me 400 is what my radius squared is. So my radius equals 20. So now I can calculate that volume using the radius I just got, 4/3 pi r cubed. So 4/3 pi times 20 cubed. And so that gives me an approximate volume of 33,510.32 units cubed. Now we get some kind of interesting problems here. And so I'm going to see if you can challenge yourself a little bit to see if you can find and work through this problem. It says a tennis ball container contains 3 tennis balls that are stacked vertically and exactly touch the top and the bottom of the can. The diameter of one tennis ball is 6.7 centimeters. How much space is wasted inside the can? So visually, what you have here is you have a can, and inside what you have is you have 3 tennis balls. And there's, it's touching exactly at the top and the bottom. So the other piece of information, I'll give you a hint, is that the diameter of one tennis ball is 6.7. So this is 6.7 centimeters. So see if you can work through that. It's kind of interesting to see and answer this question. So go ahead and try that, and then check back to the answer key for additional information and if you get stuck, and also to double check your answer. And we'll do this one together. It says the ballot box shown below is made of cardboard. if the circle slot for ballots, so that's this part right here, that circle slot has an area of 75 square inches, how much cardboard is needed to make the ballot box? So really what we're doing here is kind of a combination. I think this seems like it's a little misplaced, but that's okay. We're going to basically find the surface area of this prism, and we're going to subtract out that area of 75. So this is really not too challenging for us because we're going to find the surface area of the prism. And the surface area of the prism is the area of the base times 2 plus the perimeter of the base times the height. So my base area is 11 times 12, and the perimeter of my base is 46 times my height is 14. So I get 11 times 12 times 2 is 264, and I get 46 times 14 is 644. So the surface area of the ballot box is 644. Whoops, I forgot to add those together. 644 plus 264, which gives me 908 inches squared, because it's surface area. And then I'm going to subtract the 75 square inches, and that gives me 833 square inches of cardboard to make up that ballot box. All right, that is the end of section